Alright, hi guys, Mr. Rocco again. This will be the second video for this week, the week of December 7th. The first video was on the Coriolis effect and the Foucault pendulum. Again, those are evidence for the Earth spinning, rotating. This is a very important video, so please watch this one in its entirety. It's on seasons, what causes seasons, the diagrams for the seasons to label the special latitudes like the tropics, the equator, the Arctic Circle, the Antarctic Circle, how many hours of daylight, etc., etc. So you want to watch this very carefully, and please go back, rewind if something doesn't make any sense. If you've watched the video and it still doesn't make sense, then please come on Zoom on Wednesday office hours. My office hours are always 9 to 11 in the morning on Wednesdays. So check in. I can go over something with you, or if you have questions, anything you need help on, because this is a very important topic. All right, so there are 3 factors that affect seasons. 1, we revolve around the sun. So be careful with rotation revolution. When we rotate, right, spinning on our axis from west to east, that's what creates a day. So rotation has to do with the day. Has to do with the sun appearing to go across the sky, right? 15 degrees an hour, all that stuff. Seasons are caused by the revolution, us moving around the sun in that elliptical orbit. Second factor, tilt. We are tilted. Our average tilt is 23.5 degrees. We fluctuate a little bit, which we'll get into later on when we get into climate. That slight change in our tilt, a degree, causes global warming periods and causes ice ages. But the average tilt's 23.5 degrees. That you need to know. This number happens to be the same exact latitude for your tropics. So the Tropic of Cancer, which is the northern tropic, sits at 23.5 degrees north, and the Tropic of Capricorn is the south hemisphere tropic. That's 23.5 degrees south. So we revolve, we're tilted on our axis, and this is parallelism. Parallel, you can see the word, right? Think of math class, lines that are parallel, right? Straight, stay the same distance apart. That's not perfectly straight, but you get the idea. Our axis is always parallel to its previous position, meaning we don't swing back and forth as far as our tilt. Yes, there are times when we're leaning toward the sun, and there are times when we're leaning away from the sun, but these two, number 1 and 2, have to go together. Yes, we tilt, but we also revolve, and because we tilt and go around the sun, that's where parallelism comes in. Let me show you a picture. So these 4 pictures are supposed to represent the 4 seasons and our orbit around the sun. Position 1, let's start with 1. We are leaning in. When I say we, I mean the northern hemisphere. So this is the equator right here. I'll draw a blue line. This would be the northern hemisphere. This is the southern hemisphere. Seasons are opposite. The North Pole, the northern hemisphere, I'll go right here. Notice it's kind of tilting, leaning toward the sun. The South Pole would be it's like a teeter-totter, like a seesaw, is tilting away from the sun. So when the North Pole, leans in, that would be what season? Hopefully you said summer. So this would be the summer season over here. I'll put S for summer. So we're leaning in. The Southern Hemisphere is leaning out. So when it's our summer, it's the South Pole's winter. We move around now to the next season. Well, after summer comes what? Fall. So this would be the beginning of fall. We're not really leaning toward or away. We're kind of, and it's hard to tell in this image, where our axis is. It's always on a tilt, but in relation to the sun, it's straight up and down, which gives us what they call an equinox. We get 12 hours a day, 12 hours a night. We'll talk about that later. In this case, notice the axis. Let me clear this. This is our axis, this black line right here, this black line here, this black line here, this black line here. All 4 seasons, if you look at those black lines, they're all parallel. Let me use my straight line tool. If I draw a line, oops, that's not going to work. If I draw a line like this, I extend the axis for summer. This is the axis for fall. This is what comes after fall. Winter. This would be the axis for winter. And this would be the axis after winter comes spring. But if I draw 4 long blue lines here to show the axis, notice all of these lines are what? Parallel. And that's the key. That's what parallel. We always point in the same direction. That you should know because what star is above the North Pole? Polaris. We're always looking toward Polaris. So we don't swing back and forth. It's not that the Earth leans this way and then all of a sudden we actually physically turn and lean the other way. We're always pointing the same direction. We're always pointing in this direction, the North Pole, pointing toward the light from Polaris. The Polaris is these white arrows. So we're always pointing toward that star. It's just that when we're on this side of the sun, right, we're leaning toward the sun. That gives us summer. When we go the opposite side of position 1 and go to position 3, now which way are we leaning? We're still tilting the same way. We're still facing Polaris. It's just that the North Pole, because we revolved, and that's why I said tilt and revolution have to go together, hand in hand. We're still tilted. There's that 23. We just move around to the other side. Now, because we're on the opposite side of the sun, the North Pole isn't leaning toward the sun. The North Pole is leaning away from the sun. That gives us winter. The South Pole over here, back to position 1, was leaning away from the sun. Now when we revolve around, it appears as if they're leaning toward the sun. So it's our winter over here, it's their summer, and vice versa back here. And then these are your transitions. Spring and fall is really like your transitions. Your extremes obviously are summer, winter, right? The hottest months versus the coldest months. And then spring and fall are kind of your not so hot, not so cold in between months. So we always are tilted. That's rule number 1. Let me go back. We're always parallel and we're always revolving. And so it's really the combination of all 3 factors that affects seasons. Notice in none of these it says distance. So when they ask on our regions, hey, give a reason for the seasons. List one reason for we have seasons. Never put distance, right? And we talked about that last week. Aphelion, which is July, right? We're further away during our summertime, right? Which doesn't make sense. You would think, oh, for further away, it should be colder, right? Yes, but we're not. We're leaning away. We're away, but we're leaning toward the sun, right? So that's our summer. So it has to do with the tilt. It has nothing to do with distance. So never put distance on a regions question when it comes to seasons. Distance has nothing to do with it. Okay. So this is going to show, again, the 4 seasons. So notice the first picture, winter, right? I'll highlight the axis again. This is the axis, always on a 23.5. The North Pole's leaning away from the sun. The South Pole's leaning toward the sun. So it's our winter. So it says summer south of the equator, winter north of the equator. The sun shines directly on the south hemisphere. Notice because the southern part is kind of leaning in toward the sun, they get what they call direct rays. That's why it says the sun shines directly, right? They're getting the most direct rays, which makes it hotter, right? Direct rays are what causes the intense heat. Spring, it says fall south of the equator, spring north of the equator, right? We're going from winter into spring because next we're going to head to summer. They're going from summer into fall and heading toward winter. The sun is equal, so they call it an equinox. Everybody's getting equal amounts of sunlight, northern and southern. Then we get to summer. Again, we didn't change our tilt. Notice the slant of the tilt. It's facing that direction. It's still tilted the same way. There's that parallelism. It's just that now the North Pole is leaning in. So it says the sun shines directly on the northern hemisphere and indirectly on the southern hemisphere. So we in the north get the direct sun. That's why it's hotter up here, right, in June, July, August. And they're getting less rays because they're leaning more away from the direct rays of the sun. So it's our summer. It's Australia's winter. And then fall, again, is mirror image. Fall and spring are basically the same, except one heads into winter, one's heading into summer. So our fall, right, is heading into winter. You're falling down. Our temperatures are falling down. Whereas think of spring, right, we're springing up. We're springing toward summer, springing toward warmer temps. But again, it has to do with the tilt. So this shows both summer and winter for both hemispheres. So on the left side, again, the northern hemisphere, we're up here, right? Up in New York, in this part of the world, this hemisphere, we're leaning toward the sun. So it's summer in the northern hemisphere, and again, the winter in the southern hemisphere. So we came out of that back in July. Now we're heading into winter, December 21st, which we're going to go through the dates here in a minute. That happens to be the winter solstice, first day of officially of winter. We would look like this picture. So in about 2 weeks, this is what we're going to look like. We're leaning away from the sun. So it's our winter. We're getting less direct rays. The South Pole is leaning in. So Australia is heading toward their summer. We're heading toward our winter. This I looked up online. I had a student, I think a couple of years ago. Anyway, they asked me about, different school, right, schedule. And I said, yeah, well, everything's opposite. So they actually have their summer holiday now. Right, it's winter for us, it's summer for them. So I believe kids in Australia, they're off for about 6 weeks. They get a 6-week summer, which is less than we get, right? We have 10 weeks off in our summer. So they get about 6 weeks. They're off December and I think the first half of January, Australian students. So this is their summer break right now in December, January. They get 2 weeks off for spring break around Easter time. And then winter is when we're off, right? We have a 10-week summer vacation, July and August. They only have a 2-week. That's their winter break. They get 2 weeks off for winter, similar to us. And then they get a spring holiday in the fall. So fall, which is our fall, right? We're going into school. They get a spring break, and they get 2 weeks off there. This animation, I'm going to pull this up. This is kind of cool. Maybe I'll post this on Canvas so you can play with it. It's kind of neat. Up here on the right, you've got the Earth with the special lines. North Pole, South Pole. We haven't talked about the circles yet. Down here at the bottom is the Antarctic Circle. Up here is the Arctic Circle. Those are extreme daylight situations. For example, when we get to the first day of winter, which is in a couple weeks, December 21st, no sun above the Arctic Circle. So basically, the northern little slice of the Earth does not see the sun. And they'll go several months of darkness. And the opposite's going to happen right now at the South Pole. So when it's winter up here and it's summer down here, the Antarctic Circle and down to the South Pole, they have 24 hours of sunlight. The sun doesn't set. We are here. I put this red line. I moved us to our latitude. So if you see right here, it says observer's latitude 42.1 north. That's about Rhinebeck. Notice where the sun is. These rays coming in are down in the southern hemisphere. Why? Because it's winter for us. Summer down there. So those are the direct rays. And if you watch those arrows, you're going to see they're going to shift back up and down as we move through the calendar. And you see down here is a timeline. I put tomorrow. I'm making this video on Sunday, so this would be Monday if you're watching it Monday. So today if you're watching it on the 7th. But anyway, this is the rays of the sun. Here you can see our angle, and it'll tell you the angle right here. So our sun right now, pretty low in the sky. We have about a 25-degree angle. Pretty low. That's why you notice you might need to keep putting your visor down in the car. If you're driving around with your parents, you might see you have to keep putting your sun visor down because the sun is always blaring in your face this time of year because of a low sun angle. And then this picture on the left just shows the sun going around, the Earth going around the sun. And again, notice the tilt. It's tilted, the axis, but we're leaning away. The North Pole is leaning out, away from the sun. The South Pole is leaning toward the sun. All right, so I'm going to hit play and just let this thing run through. You're going to watch what you'll see. I want you to notice, watch the rays of the sun start to come back up. They're going to eventually get up here and come in from the top right. That'll be when this gets to June. You'll notice these rays go down a little more, and then they're going to start to work their way up as we get toward summer, toward June. So I'll start. I might stop it from time to time. So here we go. Notice the calendar if you watch down here in the right corner. So we passed the first day of winter, and now we're into January. I'm going to stop for a sec. You see how it's coming back up. Watch these arrows. See, the rays of the sun are now starting to work back up. We're heading back towards spring, and the sun is now working back toward us. Notice the angle of the sun here. It was in the 20s, now we're back into the 30s, and now it's in the 40s. We're into March, and stop, right here. So now we're into spring. So we were at 25 degrees, now we're sitting in the 40-something degree, 47-degree sun angle. So the sun's come up 20-something degrees. Notice where the sun is. directly over the equator, and that's something we'll talk about in a minute. The equator is the equinox. Those are the first day of spring and fall. The sun is direct rays are right over the equator. Easy to remember. On an equinox, the sun is over the equator. Right? Matches. Notice the axis. The axis in relation to the sun is straight up and down. Straight up and down. Is it tilted still? Yeah. Look at this picture over here. You can see it's still leaning, but in relation to the sun, it's straight up and down. It's never straight up and down. It's always 23.5, like I said earlier. But it's in relation to the sun, it's straight up and down. Now we'll hit start. We're going to head to April. Notice where the sun's going. It's coming our way. It's getting hotter, right? May. Going to get into June. I'm going to try to stop it when we get to summer, which is June 21-ish. Perfect. Notice where the sun is now. This time of year it's down here, right? Direct rays hitting the South Pole, but notice where the direct rays are coming in. North Pole, right by us. Look at that angle of the sun now. It was 25 degrees. Look at, we're now in the 70s. Never overhead. It's never overhead in New York. 90 would be overhead, right? But it's pretty high up there. That's still pretty straight up over, not quite over your head, but a pretty tall angle there, right? Going to give you your intense rays. So we're getting those nice 70-something degree rays of the sun, right? Makes it pretty hot, June, July, August. And then we'll keep going. Now the sun, you're going to see it start to go back down. And it's a cycle. Just going to keep doing that. Month after month, year after year. Sun's going to keep doing what it's doing. We're going to keep doing what we're doing. We'll get to September, right? School starts, and we get to end of September, and we hit fall, bang. So here we are in fall. Notice where the sun is again. There's another equinox. The sun is directly over the equator again. Excuse me. The axis is straight up and down in relation to the sun again. We're back down to the 40s. So we go from 25 degrees in the winter, 40-something degrees in the spring and fall, low 70 angle in the summer months. So we're in the 20s, the 40s, or the 70s, depending on what season. And then we keep going. These are the last couple of months, right? October we've gone through now. Halloween, Thanksgiving. And we're getting into December. Oops. And this is this week. And again, we're back to 25-degree angle. The sun's gone way down here now. The direct rays at the southern hemisphere. Again, we're sitting up here, and we've gone through the full year. Okay. So let's go through each season. And these, you really have to just memorize. It's no easy way. When I teach seasons every year, because they're like tricks to remember this stuff, not really. You just got to memorize the information I put on here. And again, maybe good thing to do, pause the video, take a screenshot. Maybe save these screenshots, maybe have a little folder in your MacBook of notes or something, you know. But I would memorize this stuff. So we're going to start with summer. Summer solstice is June 21. It can fluctuate. It's never exactly June 21. It can, in this case, you see I gave you 3 dates. It could possibly be. So try to remember 21, but it could also be a day ahead or behind that. So it could be the 20th or the 22nd. But try to remember 21. It's called the summer solstice. The word sol, right? Spanish means sun. This is our longest day. The sun, direct rays again are over the Tropic of Cancer. Tropic of Cancer, again, if you remember the tilt, it's 23.5 degrees north. So the sun sits directly shining down on the Tropic of Cancer. That's called the vertical. They call it the vertical rays. Vertical, right, means straight up and down, right? If I draw this line here and a perpendicular. So they call those the direct rays, right? You would be standing here. I'll put a letter X. Direct rays are coming right down on top of you. We're not at the Tropic of Cancer. Tropic of Cancer is down by Cuba and the Caribbean. We're up here. New York's up here. Which answers the question, during the day, which way do we look to see the sun? Well, if the sun is down here near Cuba, right? Basically, that's like saying, which way is it to Florida? Which way is it to Cuba? Oh, it's south, Mr. Rocco. Correct. So we always look south during the day, middle of the day especially. Not in morning. Morning it's east and evening it's west. But during the noontime hour, we look south to see the sun. Right? You put solar panels. We've referred to that in other videos. You always look put solar panels on the south-facing side because that's the way the sun is. The sun is to the south of us. So they call those direct rays. This is a little tricky. The sun rises, and they might ask this on the region. They've been asking it recently. The sun will rise north of east and north of west. So you all know the sun rises east-west. Just remember, hey, if it's summer, and the way I try to get kids to remember this, if it's summer, the sun is in the northern hemisphere, right? It's up here more than it is in the south. It's their winter. So just remember, oh, I'm going to put a north in front of east. I'm going to put a north in front of west. So the sun will rise northeast and northwest. This time of year, where would the sun rise? Well, who has the sun? The southern hemisphere has the sun, right? It's their summer. It's our winter. So guess what? Instead of sticking a north in front, you're going to stick a south in front. So this time of year, the sun rises south of east and the sun sets south of west. Just think, where is the sun's direct rays? And then you put that either north or south in front of that. This will show it. We looked at this. This is a celestial sphere, and we looked at the path, if you recall. So this long path here is our summer path. The short path here is the winter path, and the middle path is spring and fall path. So when we go to summer now, here's your north, here's your south, east is at you, west is into the screen. Notice where the sun is rising. It's rising east, but there's 3 east. There's D, there's F, and then there's due east. Well, in the summer, notice where the sun is. Again, because it's more up here in the northern hemisphere, it rises near letter F, which is northeast. So the sun is rising northeast. Then notice it takes off like a rocket. Goes way up high. This letter C would be noontime. This would be noon. And then the sun takes that path back down, comes down here. Notice where? Not west, not north, but kind of northwest. Again, why? Because the sun is in the northern hemisphere. So the sun in the summer is going to take a big path northeast, head south, back down northwest. Huge path. For us, about 15, 16 hours of daylight. We'll have about 15 to 16 hours in a day, right? So if you do the math, that leaves us, 8 hours of darkness, right? A total opposite of right now. We're in the opposite. Let's go there. So this is right now, winter, December, January. Notice where the sun is. It's down here, rising south of east, right? Here's south, here's east. This would be southeast. So that's where the sun is rising now. So if you go outside in the morning and see the sunrise, you're looking southeast. If you watch in the evening where the sun sets, tonight, tomorrow night, the sun is setting, letter G, southwest. Right, sun setting southwest. Taking a short path. Notice the length of this path. Much shorter than the summer path, right? Shorter path, shorter day. So for us right now, our day is maybe 9 hours of daylight. That's about all we get. That means we have about 15 hours of darkness, right? It gets dark at 4 o'clock, 4:30. Doesn't get light till 7:30 in the morning. So we have a very short daylight period right now. And then you have your middle path, which is your equinoxes. Both the same. Notice where the sun rises and sets. Be careful on that. On an equinox, it rises exactly east. They call that due east. So the sun, if you go outside on the first day of spring or the first day of fall, so you go out on the March or September and look east, the sun will rise exactly east. If you look at sunset in the evening, the sun will set exactly west. And again, swing south. All of these suns at noon, ABC, notice where they are. They're all in the south sky, right? Put your solar panels if you had a house. I'm going to draw my lovely artwork. My stick figure house. I've told my student, you guys that come to class, I'm horrible at art. I draw stick figures. Anyway, there's my house. If I had solar panels, I'm going to stick those solar panels over here on the south-facing side of the house, right? I'm not going to put them on this side because I'm not going to get the maximum sun. I want them on the south-facing side. And I know, talked to some of you, you said you had solar panels. So they should be facing south to get the maximum sun. Okay. This would be I took that animation I showed you before, and I took a screenshot. So this is summer. Right? This is due west this way, due east this way, north is this way, south is this way. We're up here. This is Rhinebeck, the stick figure guy. Notice where the sun is. This green line is the Tropic of Cancer. The sun is exactly over the Tropic of Cancer on the first day of summer. Again, we're up here, so we look south, right? South to see the sun, but the sun is up here in the northern hemisphere, giving us the most direct rays. Here come the direct rays from here. Fall, which is going to be the same as spring. First day of fall, they call that the autumnal equinox or the fall equinox. The date you should remember on this one's a little tricky. The date they want you to remember, and the book will say, is September 23rd. 23rd. But it can fluctuate a little bit. It can be the 24th some years. Other years it could be as early as the 21st or 22nd. So there's a little bit bigger range here. So it's 21, 22, 23, 24. But books will ask you, please remember 23. So September 23rd is the first day of fall. It's an equinox. Equa meaning equal, and nox comes from Latin meaning night. Everybody gets 12 hours of daylight. So we split our day into 2 equal parts. And so the reason that is, the sun is directly, these direct rays or vertical rays, the 90 sun I call it, is directly over the equator. Again, equinox, equator. So it's split even between both hemispheres. So because the sun is directly over the middle of the earth, everybody's getting 12 hours. Whether you're up here or you're in Australia, you're getting the 12 hours. And the sun is always rising equal. So it's not north, it's not south, it's due east. And it's due west, right down the middle. Just think middle of the road, right? You're not in the left lane, you're not in the right lane, you're right down the middle. 12 and 12. This would be what the Earth would look like. So you got your east over here, west over here, north over here, south over here. The sun is directly over the equator. Again, New York's up here, Rhinebeck's up here. We're still looking south. We got to look further south, right? The sun is lower in the sky, the further south it is. So you see how it's further south. But still showing that right over the equator. Then you got your winter solstice. So this is coming up, December 21. Again, it can fluctuate by 1 or 2 days. So it could be the 20th. It could be the 22nd. But again, the books will want you to remember 21. That's now called a winter solstice. So solstices change the days. Shortest day, longest day. Equinox meaning equal. Split down the middle. The sun is now going to again rise southeast. Remember, where is the sun? Oh, the direct rays are down here, Mr. Rocco, in the southern hemisphere, right? This is the equator here. And so the sun is down here in the direct rays in the southern hemisphere. So the sun rises southeast, sets southwest. They get the direct rays. And this time it's facing the Tropic of Capricorn. It was Cancer in June. Goes with astrology. So if your birthday, some of you might have a birthday. If you're end of December, right? Early January, the second half of December into the first half of January, your astrology sign is Capricorn, right? The goat. That's you. If you're June, I'll go back. Oops. June, here it is. If you're end of June birthday or early July, your astrology sign is Cancer. Cancer the crab, right? If you follow your zodiac signs of the zodiac. So end of June, birthday, early July, your zodiac is Cancer, your sign. And if you're this time of year or getting close to it, end of December, right? It has to be the winter solstice. So December 21 into January, your sign is Capricorn. So direct rays are again over the Tropic of Capricorn, which again is 23.5 south, same as our latitude. We're up here again. We look very far south to see the sun this time of year. And that's why it's very low in the sky, right? 25-degree angle at noontime. And this again is a screenshot from that animation. So we're up here, Rhinebeck. Look how far we gotta look way down there south to see the sun. Takes that really low angle. And again, this is west, this is east. Notice where the direct rays are coming in. The sun's rising in the southeast. Southeast. It's rising. It's gonna set over here in the southwest. So we look southwest in the evening. We look southeast in the morning to see the sun. And then this is March 21. So this is your spring equinox, which is mirror image to fall. Try to remember 21. So most of them are 21, right? Your spring was the 21st. Your winter is December 21st. Your summer is June 21st. Fall is the one that's the 23rd. But if you remember 21 and you write 21 on a Regents, they won't mark you wrong. So it's called the vernal or spring equinox. Again, everybody's getting equal hours because, again, the sun now is back over the equator. So 12 hours of daylight up here, 12 hours down here. The sun, again, is rising exactly east, setting exactly west. Again, it fluctuates by a few days. It could be the 19th, 20th, The day they want you to remember in the books is 21. Could be 22nd. So, but try to remember 21. And there's your picture again. This is the same picture as fall. Sun's directly over the equator. West rises in the east, sets in the west. Again, Rhinebeck's up here. We still look south during the day, but not as far. So the sun again is in the 47, 48 degree angle, something like that for us. Solar noon, we talked a little about that in one of the labs we did. So solar noon, when they used to keep track of time before you had a clock, and they kept track of time with a sundial, solar noon was when the sun reached its peak for the day. So if I go back for a minute, excuse me for bouncing back here. Here we go. So these are solar noons, C, B, A. When the sun reaches its peak on the arc, so the highest point on the first day of winter, or the highest point on the first day of spring or fall, or the highest point on the first day of summer, or any day in between. The highest point on that day is called solar noon. Let me fast forward. Never at the zenith. The zenith is a term that means 90. Again, if I make a perpendicular here, I do this. All right. For places inside the tropics, yes. If you live at the equator, if you live at the tropics, the sun can be at certain times of year directly overhead. But again, if you're standing on the ground at letter X, we never see the sun here. The sun is out at 90. All right. It gets up to 70. Might be here. That might be a 70 degree angle. It gets down here in the winter at about a 25 degree angle. Spring and fall, it's here. But we never see the sun at 90. It's never directly overhead. And again, we always look south during the day. So you go outside in lunchtime, you're looking, that's the direction you're looking. You're always looking south because it stays between those tropics. New York's up here. The tropics are down here in the equator. So we always look in a south direction to see where the sun is. It stays in between those tropics, which is south of us. So this just shows us, that's me. We're north of the equator, north of the tropics. Here's the Tropic of Cancer. Here's the equator. Here's Tropic of Capricorn. Again, we're always above all three lines, so we look south to see the sun. This is summer. The sun would be over here. We are leaning toward the sun, North Pole, so it's our summer. The 90 sun, or the vertical direct rays are called, are hitting the Tropic of Cancer. So on the first day of summer, the rays are over the Tropic of Cancer. Now we're going to go to the next one. Spring and fall. Again, it looks like it's straight up and down in relation to the sun. Remember, we don't change the tilt. It just appears that way. But this would be what the diagram would look like. This is fall and spring. So this is September and March. The sun is directly overhead of the equator. So the direct rays are hitting the equator. These are equinoxes. We're up here. Again, we look south to see the sun. 12 hours in the north, 12 hours of daylight in the south. Everybody's getting 12 top to bottom. And then this will be coming up in a couple weeks, winter. Now it appears as if we're leaning away. This is our winter. This would be the southern hemisphere summer. Notice where the 90 is now. The direct rays have shifted to this tropic, Capricorn, 23.5 south. Again, we're looking very far south to see the sun. That's why it's a low angle. This will just show the path. So if you're looking south during the day, that's me again. I take pictures that I have on my camera and put little clips of me in there. So that's in my summer outfit. Anyway, you're looking south. Sun's going to rise southeast in the winter. It's going to go low path. Again, for us, about 25 degrees, roughly, for noontime sun. And then down again. If I do spring and fall, it's going to rise. Now, this will come up too. They'll say, how many degrees will it shift between seasons? Always the same as our tilt. So what do I mean by that? Let's say they'll say the sun on the first day of winter is 25 degrees at noontime. So the first day of winter, right here, this sun, is 25 degrees. What will be the sun on the first day of spring, right? You go from winter, the next season is spring. What will be the angle of the sun? You just have to add the axis tilt, how many degrees, which is 23.5. So meaning if we were 25 degrees on the first day of winter, you're going to add 23.5 degrees to that number, which would give you what? 48.5 degrees. So that means on the first day of spring for us, if we were 25 degrees in winter, we'd be 48.5 degrees on the first day of spring. I have seen questions where they'll skip a season. They might say, all right, we're 25 on the first day of winter. What will be the angle of the sun on the first day of summer? So now not only do you have to add 23.5 degrees once, you actually have to add it twice. So you're going to take that 48.5, you're going to add another 23.5 to that. So every season we change by 23.5. Just again, it's like the tropics. They're 23.5 and the same number as our tilt. So that 23.5 is a very easy number to remember. It's our tilt, it's the tropic latitudes, and it's how many degrees the sun changes season to season at noontime. So if I add 48.5 and 20.5, right, that gives me 0, carry the 1, 11, 12, carry the 1, 4, 6, 7. We're going to be at a 72 degree angle on the first day of summer up here. So just be careful with that. So if we were 25 degrees in winter, we'd be 48.5 degrees on the first day of spring. We'd be 72 degrees on the first day of summer. You always add it, always either add or subtract. They might go down, but it's always a difference of 23.5. And that shows the same thing. So 23.5 between these suns, noon suns, 23.5 between these. Always the same as our tilt, 23.5. And that just shows that paths again. So this path, hopefully you're going to tell me what's this long path. This would be which season? Longest path, longest day. Hopefully you said summer. Good. This short path, shortest arc, shortest day. So that's coming up. That's our winter. And middle of the road is spring, SP, and fall. Good. Why does the sun rise and set at different locations during the year? Again, they're just saying what causes the seasons, and the answer they're looking for is due to the tilt. So again, this would be summer when we're leaning toward the sun. That's our summer. The sun is rising north of east, right? Because the sun is north of east. When we lean this way, right, east goes this way. That's due east. Notice where the sun is. Sun's up here. Sun's north of east, right? This would be spring and fall. Sun's rising exactly east. And this would be winter when the north pole is leaning away from the sun. East shifts this way. That's due east. The sun is down here, southeast. Again, these are those special lines where the sun is overhead, or direct rays. They call them vertical rays, straight overhead. Tropic of Cancer, which again is 23.5 north. That's going to be over that. The sun's going to be over that on the first day of summer for us. That's June 21. It's going to be over Tropic of Capricorn in a couple of weeks. That's down in the southern hemisphere. That's the first day of winter for us, December 21. And the sun will be over the equator on the equinoxes, March 21, September 23. Fall and spring equinoxes, sun's overhead. So this again, you might want to take a screenshot of this and memorize these dates. So my advice, I would take a screenshot of this. I would go back and take screenshots of this stuff here too. You know, these seasons. You can look at my notes and take screenshots off those too if you want. But I would definitely memorize the information on these slides for the 4 seasons. There's no real like trick to remembering this stuff. You just have to go through and think about it, you know. So this is showing the special lines again. The Arctic Circle, the Antarctic Circle, Tropic of Capricorn, Tropic of Cancer. And I was talking before earlier in the video about special situations. There is the axis on a tilt. So the day-night line is splitting the Earth into 2 parts, darkness and daylight. Our Earth is always 50% illuminated and 50% dark. So the day-night line never changes. It's always straight up and down. Cuts the Earth into dark and day. And if the sun's on this side, obviously you can see this is the half that's illuminated. This is the half that's dark. So when you draw in the day-night line, and we're going to do this in class this week, I attached a blank diagram we're going to label. It's on, if you go onto Canvas and you see where this video is, right below that it's going to say season diagram blank. You're going to print that out, especially you people that are remote. Please print that out, and you're going to try to label all the special lines, these special lines. Arctic Circle, Tropic of Cancer, Antarctic, etc. We'll do this in class this week as well. I want to make sure you know the special lines. So you got your day-night line, goes straight up and down. The axis is on a tilt. This angle is 23.5 degrees. Okay. So what happens then is, if the Earth rotates along the axis, right, and the Earth goes west to east, imagine this side of the Earth coming at you and this side going into the board or into the screen. It's going kind of out and that's going in like that. That means on the first day of summer for us, this would be summer because the axis is leaning toward the sun, right? Our summer. Any spot up here, if you go above the Arctic Circle, this section, I'll kind of circle it, never goes over to the dark half of the Earth. And so what that means is anything above this Arctic Circle, their latitude is 66.5 north, never sees the dark side of the Earth. They're going to have 24 hours of daylight. And that's a special situation, meaning the further north you go in the summer, the more daylight. If you traveled to Canada in the summer, I don't know if any of you ever took a trip to Canada in the summer, they have even longer days than we do. Or if you go to Alaska in the summer, or even just go up to Maine. Maine is further north. Any place like that, you're going to have much longer days compared to New York, compared to where we are in Rhinebeck. And then the opposite is going to happen in the winter. Right? In the winter, it's going to be reversed. But let's stick with summer for a minute. So we have 24 hours of daylight here. If I were to go to the South Pole, okay, and I go to the Antarctic Circle, notice down here, I'll circle it. Anything below the Antarctic Circle, remember, we're rotating along this axis, this tilted line, coming out of the board, going into the board. This section would never go onto the illuminated portion. Therefore, it's going to be 0 hours of daylight. So if you go to the South Pole in our summer, they don't see the sun. It's going to be just pitch black. And they're going to have that for several months. So, yeah, on the first day of official summer, it's going to be 24 hours. They're slowly going to lose daylight, but it's going to be several months. You're talking, if you go to the Alaska, especially northern Alaska, you're talking June, July, and August. Especially those 3 months, they're going to have very long days. Very, very long days. And down here, just the opposite. They're going to have hardly any sun June, July, August. Right? They're in their winter months. And then everything would flip-flop. So you're going to have these 24-hour situations. Who has the 24 hours? If you go to the Arctic Circle, the North Pole, anything above 66.5, they're going to have 24 hours of sun in the summer, our summer. And if you go to the South Pole right now, so in 2 weeks, or even now you could go, they're going to have almost 24 hours. It's close. We're only a couple weeks away from winter. So if you go to the South Pole right now, 66.5 south, they're going to have the 24 hours of daylight, excuse me. If you go to the North Pole right now, right? Santa Claus, ho, 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 no sun, right? It's dark up there. Northern Alaska, Canada, Maine, the days are real. I mean, our days are short enough, but if you go further north this time of year, it's very, very dark up there. So you have these extreme situations, and that's, again, based on this picture right here, because this day-night line stays straight up and down vertically, but the axis is on a slant. So because they're not the same position, that's why you have extreme cases, because you have this 24 hours of daylight in the summer and then darkness in the winter, and the same thing down here, 24 hours of darkness during our summer and 24 hours of daylight during their winter. Right? So you have these extreme cases. Okay, I know that was a long video, and I apologize for that, but seasons is a really important topic in astronomy. So we're going to actually in class I'll print that diagram out for you when you come to class this week, and we will be drawing and labeling the special latitudes on there. You students that are home, if you could print that and maybe take a screenshot of this thing or look at my notes, you'll see this, and you want to do all of the stuff you see here. You want to shade in the dark half. You want to put the special lines, the tropics, the circles. You want to label the axis, put the dates, is it summer, is it winter, so you know the seasons and the position of the Earth for each season. And if you have any questions or concerns, please don't hesitate to jump on office hours. Again, 9 to 11 on Wednesday, and I could try to go through this with you if you're stuck. Okay. Have a good week, and I will talk to you soon.